Welcome. This is Peter Vickerslund with Fundamentals of Public Health Engineering. This is the first in a series of videos looking at on-site treatment options. In particular, we're going to think about septic systems. At the conclusion of watching these videos, we're going to be able to design a septic tank and a subsurface soil absorption system that is going to be consistent with Virginia state regulations. When we think about on-site wastewater management options, we can essentially go through a series of steps. First, we can think about wastewater modification, where we can have flow reduction. This is essentially an example of this would be low flow toilets. If we think about pollutant mass reduction, we can think about separating septage from black water. And then if we go forward, we think about pretreatment with the septic tank. This is going to be an anaerobic process. We'll learn more about that. Anaerobic. We can also think about aerobic treatment. So septic tanks are anaerobic. There's also aerobic possibilities, but much less widely used. Then we think about subsurface soil absorption. So there we're going to have some capacity to spread liquid wastes out. And the four options that are on here are all choices that people make depending on the local conditions. If we want, we can get a little bit more exotic. We can think about evaporation systems where we rely upon evapotranspiration or lagoons or evaporation infiltration lagoons. A lot of different options. We're not going to go into those details here. We could think about land application where we're going to apply treated wastewater to the surface. We can also be thinking about treatment for surface discharge. So these are literally mini treatment plants that are package plants or something like that that allow for treatment, filtration, nutrient removal, and disinfection. We can think about all this in terms of a flow diagram where if we start with some wastewater flow, we can think about modifying that by flow reduction or reducing pollutant mass. We could think about pre-treatment. Again, that's going to be our focus here, with particularly a focus on septic tanks. And then we can go and start to think about subsurface soil absorption to deal with the liquid. When we consider on-site wastewater treatment, one of the things that we have to think about is actually how much wastewater is there that's going to be produced. So on average, the water use in terms of gallons per capita per day is about 50 gallons per capita per day. And essentially, if we convert that into cubic meters or into liters per person per day, it's about 190 liters per capita per day, or 0.19 cubic meters per person per day. So this is typical water use, and we can think of the fact that 100% of that is going to be transmitted as wastewater. How that water is used is very location specific, but essentially a good chunk of it goes down the toilet. A lot of it is used for clothes washing, a little bit less for showering, faucets, and so on. So we could think about where are the different sources for that water as it goes into the local wastewater treatment system. This is the same idea, but in a tabular format, where essentially we've got a water closet, and that would literally be a toilet, where it was 40% of the use, laundry is 20%, bath and sink 30%, kitchen 10%. So these are kind of rough percentages. As you go from single family to multifamily to luxury homes, you see big changes in water use. So single family homes, 50 to 75 gallons per person per day. And then as you go up to a luxury home, it gets to be larger than that. A few definitions. So domestic wastewater is going to be the combined wastewater from a community. So household, commercial, and industrial wastewater. All of that combined is going to be domestic wastewater. Household wastewater is going to be the combined wastewater from all household activities. Black water is wastewater that comes from flush toilets and aquaprivies. It's about 40% of household wastewater. And then last is gray water, which is going to be the wastewater from all household activities except flush toilets and aquaprivies. So this is all the water that goes down the drain from food preparation, showering, bathing, washing, and so on. All of those things besides what goes down the toilet. We want to explicitly define black water as being toilet wastewater. So toilet wastes are the main portion of conventional pollutants, and they use a lot of water as we flush them. So typical toilets in America today use about 1.5 gallons per flush. Varies depending on the age of the toilet, but that's a good number to start with. We can compare black water and gray water in terms of its characteristics. And key things to point out here is that the COD is higher within black water than it is in gray water. We see similar BOD5 between the two. Suspended solids are higher in black water than they are in gray water, and so on. If we look explicitly at gray water, we'll see that the COD to BOD5 ratio is much less than it is in sewage and it is in black water. And essentially what this means is that gray water is more biodegradable. So we can think about that in terms of trying to design our system. Do we have the typical relationship between the amount of black water and the amount of gray water, or do we have excess gray water for whatever reason? These are things that we need to be thinking about when we're developing our system. The Virginia Cooperative Extension here at Virginia Tech has spent a lot of time trying to think about the design of on-site wastewater treatment systems. And so this is from a flow chart from one of their publications, and thinking about as we go from raw sewage, we have some sort of separation process where we're going to remove solids, and that might be the septic tank that we're talking about, or we have some physical screening, and that is often going to be in the context of what we're thinking about for on-site treatment, a septic outlet filter. This is the focus where we're essentially following this line where we're going to remove solids, and then we're going to have some sort of disposal of our liquid effluent. This other side of this diagram, this is much more conventional treatment. So this is what we have, where we have a sewerage system and a centralized wastewater treatment plant.